And then for the workshop, here, this is the homework, I guess. Yeah. This is a 3JS the experimentation. I give you guys the boilerplate code here. And then, I don't know, in the Grasshopper Python workshop at that time, I created the ice cake, data visualization on the glove. So this is the projection, spherical projection, and then the loops things. So this is Python combined. And then I challenge you guys that, let's say, port Python code to the TypeScript and then create the geometry, yeah, and then dump this mesh to the scene to create some glove things here. This is the assignment. And then, you know what, for the mapping, the remap is really important, to be honest. So what it does is basically, just think about it. We have a 1,200, for example, but the screen size is let's say the 400 pixel and 400 pixel. We need to remap, just like a different type of projection. So for example, we have this many number. It has a minimum and maximum, correct? And also we have a screen, minimum and maximum, correct? So we need to resize, reproject the data scale to the screen scale because we're gonna draw something on the screen, right? So here, using the remap, I just put the remap function here so you guys can use it. So here, I'm just commenting out. I simply remap the data. Then now we can see the correct scale, like a proportional scale. Yeah. Obviously, the first data is not like 1,200 pixel. It's not. However, this is their own like a bar scale. I mean, if you guys familiar with the D3 or N chart, they already provide like some axis. So we will visit later, but my point I want to make in this exercise is that we have a linear, these different types of projection. Let's say we can consider as a projection actually, because it's all about like translating the number. Okay, so if I change like one more zero here, yeah, so we can get like an entire like a picture of the data. Yeah. So this is a remap. We can also consider as a projection things. And then we have a scalar plot here. Yeah, the same concept, but bar chart only we need to take care of the height, right? The bar chart usually we can visualizing at least 4 dimensions, right? X dimension, Y dimension, and then the circle size, right? And then color, right? You can put like a more dimension. We can visualize multiple dimensions throughout the simple 2D scalar plot. Correct. So here, I created boilerplate code, same data, and then I just literally visualize. Yeah. Some of the point is out of the canvas, all the way down. Yeah. Makes sense, right? So we need to remap, right? So this is the result. The remap. Really? It was working? Okay, correct. Yeah, now they scale entirely, right? Holistic way. So now we can see the relationship between points correctly in a one scale, right? And then, but by the way, the most important thing you need to remind is that people, I mean, particularly for the designer, they used to use the coordinate system from here, 0, 0, right? But keep in mind, the canvas graphics, particularly the web graphics, they consider these points become 0, 0. So along the x-axis and y-axis. Here, what I did is I basically convert, like a reverse the y-axis. Yeah. So this is the function. So not function. This is sort of a simple math. So I apply the offset because I don't want to put this point all on the edge. So I apply like a 20 pixel. Let's say maybe I can apply 10 pixel, little offset, yeah. And then I fit. We have a little margin, yeah, little space. So which looks better, right? And then we have the height canvas. From that point, and then we can reversely print the dot along the y-axis. So this is just simple equation. Otherwise the data is just upside down, because take a look at the screen. So this is a y-axis. It's like an upside down. So we human being is not familiar with this kind of the coordinate system. So that's why I put this command. Yeah. So I reverse the y, the axis things. So collision detection. So I mean, collision detection is, I think, as I said, this low-level sort of API can be used in multiple ways, like a game or mapping or agent-based design, or we can actually replace let's say we have two boxes and then we can check whether they collide each other or not, right? We can replace this box, not rather than box, we can replace with some other data set. Yeah, I mean, there's a lot of freedom. So for example, there's some technical documentation in the end here. So there's some idea toward exit aligned bounding box, which is very light and fast algorithm to check whether they are overlapping or not. So yeah, I mean, I copy this file and then I migrate this code to the class implementation here. So I create the canvas select class as we learned yesterday. No, they did the day before yesterday, because they were trying to pretend, So I implement the class here, x and y and with height, and then it has a function, it's collide, right? And it has a function to render, correct? And for the implementation of the class, I mean the object, then I create two different rectangles here, right? With this parameter, yeah. And then I'm check the collision between two objects. So if they check in terms of the render, if they check they collide each other and then they become red. Otherwise, they become green here. Yeah, they become green. Yeah. And then the one thing I want to mention to you guys is, for example, save. Come on. So I print two rectangles here. So I'm trying to inspect, okay, is there a collide? No, false, right? Obviously, they're not collide because there's space between them, right? But what happens if I make them collide each other? Yeah, they become red, right? And then according to the algorithm here I designed, if they collide each other and then they remember who overlapping on top of me, who hover over me, right? So for example, I print these two rectangles and then is it collide with others? It's true. So other has the other rectangle. Yeah, the other rectangle. And then they point each other. Okay, let's say I'm this big rectangle is me, and then maybe this is small rectangle, we collide. And then this inside of the, it has their own variable called others here, other. And the inside of the variable, they have a point to indicate me. And also I have a, I'm trying to describe some graph system. Yeah, they collide each other and then trying to remember who triggered me to be collide. Yeah. So this is actually using the functional programming, other things is really hard to make this kind of environment. But using class fashion is really easy, just one line of magic. Yeah, just like this, and then I just want to append it. And then another, I want to add myself to that variable. Yeah. Yeah, so this is the implementation. You guys can see it. And